Hi everyone, welcome back to BSc Chemistry Study Room. If you are new to this room, please subscribe for more video updates. And if you have already subscribed, please click on the notification button for more video updates. Today in this lesson, we are going to discuss under THEVENIN'S theorem. We are going to see how we can find current inside a Thevenin circuit. Here is a Thevenin circuit, so we are going to see how we can obtain a current flowing through a Thevenin circuit. So to find current flowing through the circuit, here is the procedure. Procedure number 1 says remove RL, that is R load, from the circuit terminals A and B and redirect the circuit. That is, the circuit now becomes an open circuit. So this is the R load resistance to be removed, and when removed, to redirect the circuit again. So here is the circuit we obtain when removing the RL. So this, and replace this with VOC. This VOC is a voltage drop under R2. Now, using Ohm's law, V is equal to IR, calculate the value of I in the open circuit voltage, VOC, when RL is removed. So now we are going to calculate our current using this circuit, and using Ohm's law, V is equal to IR. We are going to find the current flowing through this circuit, and we know this VOC. VOC is a voltage drop under R2. So now we are going to calculate current flowing inside this circuit. So now using V is equal to IR. And now inside this circuit we have to find R equivalent, where R equivalent, when looking the circuit, this internal resistor small r and R1 and R2 are all in series. So now R equivalent is equal to R plus R1 plus R2. So now we are going to make I to be subject. I is equal to V all over R. So now in our circuit, or in this circuit, we know our voltage is E. Therefore, E all over R equivalent, that is R plus R1 plus R2. So now we are to obtain VOC. And VOC now will be equal to I. So now before the R, we know VOC is a voltage drop across R2. So we are going to write R2. So now replacing this value of I inside this VOC, VOC will be equal to E all over R plus R1 plus R2 dot R2. So therefore now VOC will be equal to E times R2, that is this R all over R plus R1 plus R2. So this is how we obtain Thevenin's voltage, that is VOC, from this circuit. So now step number 3 says imagine the battery to be removed from the circuit and redirect the circuit, leaving its internal resistance R. Then look inward, direct to obtain the equivalent resistor, that is R Thevenin's, of the network. So by removing the battery and also redrawing the circuit again, leaving its internal resistance small r, and in order to obtain the R Thevenin's, that is the R equivalent of the circuit, we look directly inward the circuit, and we will find that this small r and R1 are in series and parallel to R2. As we have seen that R2 is in parallel to R1 and the internal resistance small r. So now we are going to obtain our R equivalent, that is R Thevenin's, using these relations. So now this implies that R Thevenin's is equal to R2 into R1 plus R, that is the internal resistance, all over R2 plus into bracket R1 plus R. number 5 says connect RL back to its terminals from where it was previously removed. This is RL and we connect it back from where it was previously removed at the first time. So now after connecting it back, then finally calculate the current flowing through RL using Ohm's law. So now by using VOC is equal to IR. And when looking at the circuit, we can see that RL and R Thevenins are all in series. So therefore, R equivalent will be equal to R Thevenins plus RL. So now making I subject of the formula, I will be equal to VOC all over R. So therefore, I is equal to VOC all over R equivalent. This is R equivalent, that is RT plus RL. So this is the end of our today's lesson. Don't forget to like, comment and subscribe please. And if you have any question, please drop it in the comment section below. Thank you for watching. Tata for now.